Okay, Math 94E. Today, 1B, subtracting integers. Here's what I used to do in front of a class. I don't have the audience now, so I can't make it work. I'd say there are 3 names for this. And I'll just draw one for you. And I'd say, can anyone give me one of those 3 names? And usually I'd get someone to say, that is for minus or subtract, and that's true. Any other names you can think of that? Okay, so now I'll put this on it. And I'll say, don't call it minus 3. Now can someone tell me what a name for that is? And now that it's in front of the 3, we might get someone to say, that's negative. That's good, true. That is called negative 3. If it's like this, it's called 7 minus 3. So now we've heard names for it are minus, and names for it that would be negative. So now if it's that, we call it negative 2. So don't call it minus 2. And so you can't call that minus minus 2. And I'd say, we can agree that that's called negative 2. Does anyone have a guess about what that would be called? And it wouldn't be called negative negative 2. It wouldn't be called minus negative 2. And it's certainly not called minus minus 2. And the name of that is opposite. Yeah, opposite. So that thing that we have there, I'm going to call it a dash. I call this sign a dash. That's what I call it. That's a name I've given to it. So that when I'm typing it on a keyboard, I can just hit the dash key and get on with my business. And not worry about whether I'm supposed to call it minus or negative or opposite of. But it has all 3 names. It represents one of these 3 things. One of them is, the first thing someone would say, minus, is, it's called minus when it is right behind a value. Usually a digit, but sometimes it'll be a letter, something like that. But when it's behind a value, it's called minus, and that's the first way we would assign the name to it. If it's not minus because it's not right behind a value, it would be called negative. The second thing that we came up with. Whenever it is immediately before a value. Now, if you catch it because it's right behind a value, call it minus. It's over. You call it minus and it is named. But if you get to one that's not a minus, then you continue to see if it's called a negative. And it will be called negative if it's immediately before a value, which is usually a digit, sometimes a letter, sometimes a fraction. But if it's immediately before a value, mostly a digit, then it'll be called negative. And it's called the opposite. So you don't just call it opposite, you call it the opposite of whenever it is in front of another dash. So the first thing you do is say, can I call it minus? That depends. Is it right behind a value? So it's minus, on with the game. Can I call it negative? Well, that depends. Since it wasn't a minus, it's sitting right in front of a number, a digit, a value. If so, you'd call it negative, and if not, you call it the opposite of. Now, the opposite of can only occur when you have 2 dashes in a row. There's something else going on, though. We must insert, I don't say add, a plus sign in front of any dash that should be called minus. Now when you insert the plus sign, you turn something from what used to be minus, which is not something we're capable of doing, into a form of addition. It still has the dash to represent the reversal of the sign of our value? Because the dash doesn't go away, it doesn't get crossed out and replaced with a plus sign. You insert a plus sign in front of any minus. And it turns into plus, and it's either going to be plus negative because it's already negative, fitting the negative that we had. Used to be minus, but now we got the plus sign, it's become plus negative. Or plus, and now it's part of a string of dashes, and therefore it's going to be plus the opposite of, and other stuff's going to come behind it, and that's it. We must do that all the time because there is no minus to work with. We don't work with minus. When you get as far up as calculus, you will find that things that we create called expressions are the sum of terms. Always. Some of the terms are positive, some of the terms are negative, but it is always a sum of terms. It's not like, yeah, it's kind of tricky, folks, because with a sum, we got sometimes we're adding and sometimes we're subtracting. Absolutely not. We are always adding. Sometimes the addition is a negative number, sometimes it's a positive number, but there is no more minus. Once we do the blue step of putting in plus signs, we got plus between all our terms, so we can clearly tell when terms end and new terms start. And we can do addition once we reduce what each term actually is to work with. So that's the deal. So we're not going to learn a special rule for minus and a whole group of other processes. What we're going to do is use that concept of, if we see a dash right behind a digit, later on, right behind a variable maybe, we're going to squeeze a plus between what's in front of it and that old minus sign and turn it into plus dash. Now plus dash could be plus negative, could be plus the opposite, but plus. We're no longer going to say minus. We don't kill the minus sign off and take it away. We convert it to plus, generally the opposite of. Every once in a while it'll be plus and force us to say negative instead of that. But that's what we're going to have to do so we can get to work on some of that stuff. So I want to get to work on that right now because I want to show you how to do subtraction. And it uses that blue rule. I do it in blue because all my inserted plus signs initially go in blue, so that when you're watching, if you see it in blue, you'll say, oh, he inserted that. It used to say minus, now it says plus and then a dash behind it. Creating addition allows us to combine terms. That's the key. We are combining terms. Addition allows us to combine terms. What? Combine terms. Later on, a little bit later in the course, we'll learn about combining like terms. It's about adding terms that belong together. When they're all numbers, they all are like terms and they belong together. We must turn it into addition. The insertion of plus signs where there used to be subtraction, plus in front of the dash, allows it to always become that. Now there's another thing we have to do. Dashes on any one term cancel in pairs. We're going to look at why. On any one term is important also. You don't say, oh, I see two dashes, this is going to be positive. No. You have to get all your terms set up with your plus signs, and every time you start a new term, you start the count over of how many dashes does this term have before I begin my next term. Because each term is either positive or negative when it's reduced, and we have to find out what the digit is that goes with it also. But when we see a plus sign, that's the end of that term. Let's set up the next and get each term to tell us what they actually represent before we go combining them. Okay. On any term, every dash is called the opposite of. Don't put a period yet, though. Except the last one is called negative. Now, some people think the work I'm about to do makes them dizzy. I am going to show you how it makes me dizzy. So what I'm going to do is I'm going to put up a single dash with a 1, and 2 dashes with a 2, and 3 dashes with a 3, and 4 dashes with a 4, and that's as far as I go, because I find this word dizzying. It's dizzying for me. Every dash turns you around. So, when we are looking at this, we are on the number sign and we are good to go to the positive. And then we have a dash that turns us around. So I'm going to take my steps on the number line and you're going to watch me do it. And I don't take my 1 because I got this dash that makes me turn around and take 1 step. And I go into the negatives, and that's why I wind up at -1. However, when I do this 2, I'm going to start at my 0, and before I take my 2 steps, I'm going to say, you know what? Take the opposite, so turn me around. Let me go negative. Wait a minute, there's another one. In front of the 2 it says a dash. That's -2, so I'm going to take my second dash, and now I'm ready to take 2 steps, and I'm going to wind up to the positive with +2. I don't write plus, I just write the digit 2 because it's implied to be positive. Now -3, and I told you this is dizzying. This is dash 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 3, right? It should formally be called the opposite of the opposite of the -3. So the opposite of the opposite of -3. Now the speed with which I say that can play a big role in this. Because now if I say that I want it to be the opposite of all that's enclosed in green here, I can say I want it to be the opposite of, and in the green say really fast, the opposite of -3. Therefore I'm going to say I want the opposite of 3 winds up at -3. Now dizzying, right? Here I am. I'm just going to count them dashes. Ready? There are 3 of them. Here we go. The first dash, going negative. The second dash, going positive. But the third dash, going negative. 1, 2, 3. -3. That's because I did 3 spins, and every pair of spins puts me back to positive. So every time that I have a pair of dashes together on one term points me back to positive, and if there's nothing left, I go positive and I do it. But if I got 1 more, and I spin 1 more half turn, and I'm going negative. Because pairs will get me the opposite of negative and make me positive. Now this one, is the opposite of the opposite of the opposite of -4. I'm going to have my 2 dashes, and the red stuff makes 4. And now I want to see what that makes. And that should make plain old 4, also known as +4. Why? Because I want, ready for it? The opposite of the opposite of the opposite of -4. So I want the opposite of the opposite of what red makes 4. And now I say it this way. I'm starting to deal with the green thing. I want the opposite of -4. I just want a 4. That's why it's dizzying for me, right? The concepts can be dizzying for students, but in pairs the dashes go out. So here I am. I have had no dashes yet, and I'm going to do 4 of them before I take my steps. Ready. First dash, pointing negative. Second dash, pointing positive. Third dash, pointing negative. Fourth dash, pointing positive. And now I do my 1, 2, 3, 4. I definitely wind up at 4, but my 4 winds up positive. And what happens in every class of 20 students at the beginning of the semester? Someone in the back goes, do 5, do 5. And I say, no, I cannot. Why? Usually I'll get someone to do it and I'll be faking it or maybe meaning it and start to fall over on my desk. And leave him alone, he's dizzy. Exactly. I'm not going to do more than that. I could. Not that I would want to. Eventually I'd pass out, throw up, do something disgusting, right? We don't want that. But the concept is every 2 spins gets you a full turn back to positive so that every pair creates cancellation. That's within each term. So those plus signs, additions have to be set up to tell you when to restart the counter on each term to see what's positive and negative. The biggest one we have is what people call a double negative. It's not a double negative. It's the opposite of negative, right? This is not negative negative 2. It's definitely not minus minus 2 or minus negative 2. It is the opposite of negative 2. So yeah, there are two dashes. You want to call it a double dash, I'm with you. You want to call this a quadruple dash, I'm with you. But it's a double dash on the same term. And by the rules that we have for what naming conventions we'll go with, that would be called the opposite of negative 2, which will get us 2. A lot of people can follow that one, and some have trouble with this. It's the opposite of this red thing. But the red thing is the opposite of negative 4. So what I want is in black the opposite of 4, which is what it stands at for that moment. But then I say, wait a minute, let me rename that. The opposite of negative 4, positive 4, and it gets that way. And it doesn't matter how many you have. This leads to the even-odd rule, right? I don't call it the even-odd rule, but some people do. Whereas in each term, okay, on any one term, if the number of dashes you have is negative, then the term is, if the number of dashes that you have is odd, then it's going to be negative. End of rule. But wait a minute, what about if it's even? If it's even, then you don't make it negative. And if you don't make it negative, it's positive. And if you don't make it positive, it takes care of itself. So the idea is, if you have an odd number of dashes on a term, that term is negative. End of term. What about if it's even? Don't worry about it. It's positive because it started positive and it gets to finish positive. What if there are no negative signs on it, which is not an even number? That's fine. Nobody said to do anything with negative when there are no negative signs. That's going to be our rule for multiplication. It'll play out if we have more than 2 factors in any term. Factors, that's weird. I haven't touched on that a lot yet. But factors deal with multiplication. We're not into that yet. We're trying to really deal with some of this that goes on here. So what we're going to do is to deal with subtraction. Number 1, insert a plus sign in front of any spoken minus. That means you gotta do work before you get to this step. You have to know if it's called minus or not, which is it follows a digit. If it's digit and then a dash, squeeze a plus sign in between. Number 2 is if the number of dashes in a term is odd, make the term negative. Now that is sounding like it might be too much, too powerful, right? You don't want to give someone something that's too powerful. I'm not afraid to give you something that's too powerful, because you'll use that all the time. But if it has a single dash, it's going to be negative. If it has a double dash, it's going to be positive. If it has a triple dash, that's rare, but we're ready for it. And then, to handle the toughest problems that come our way, I'll say combine all positive terms combine all negative terms and then combine the 2 terms once as a positive plus the negative. You don't want to do it all the way across the screen. Well, like, that's rough. I'll show you how when we get to that. This is how we handle all the problems that we have to do. What I want to do is give you a series of 2-term subtraction problems. They start as subtraction problems. They immediately become addition problems if they were subtraction problems. And we're going to work them out. So you can do these quickly, slowly, stop the video, replay it, whatever you need to do. But I'm going to put a series of subtraction problems on the board and let you go through the process of looking at it to see if by the end you can do the ones that show up. So we're going to go 4 minus 6. We're going to go 8 minus 5. We're going to go 3 dash dash 5. That should be called 3 minus negative 5, but if you're writing it, you might just write 3 dash dash 5 and you're ready to proceed with what's coming after it. 4 dash dash 2. Dash 5 dash 3, that's called negative 5 minus 3. Dash 2 dash 7, that's negative 2 minus 7. Dash 8 dash dash 2, that's negative 8 minus negative 2. And dash 7 dash dash 7. And if we can get through all these, we really have nailed down the concept of converting subtraction to addition and how to do the addition that results, which goes back to what we did in an earlier homework or lecture 1A if you're looking to go back and review that stuff. So if I need to insert a blue plus sign, I will do that by rewriting what we have here. So here I have my 4-6. In fact, I can guarantee you I'm going to have to insert a plus sign in each one of them. So I'm just going to write each one. 3 double dash 5, 4 double dash 2, 5 dash 3, negative 2 dash 7, negative 8 dash dash 2, and negative 7 dash dash 7. This brings up the point where someone's like, come on, Mr. K, I already know how to do this. Well, great, because you're on the video, you go through it quickly, you get them all right, and we're good. You can move forward doing what you already know. However, if you don't learn the foundational material that I teach you here, because you're like, I remember my old teacher taught me this like catchy rhyme of how to get this done, like keep, change, whatever. That may not get you where you gotta be all the way through the math that we have to deal with. Whereas understanding it, doing what we're trying to learn here, will establish a foundation from nothing, if that's what you came in with, to be really strong as I build on those blocks throughout the term. So you're welcome to do old tricks that you know, but they gotta be there 100% of the time with you understanding what you're doing if you're gonna reliably be able to get through everything in the course. So, let's get this stuff done. 4-6 called 4 minus 6. I heard minus, so I go 4 plus dash 6. That's 4 plus negative 6. And now I proceed to do the work of adding. This stuff here about combining the positives, combining the negatives, and then combine only once, that's really for if you have more than 2 terms. But it doesn't make anything wrong. All the steps that I write in my recipes are, if it exists, combine all positive terms. So if there's more than one positive term, you combine them. If there's more than one negative term, you combine them. And finally, only one time do you combine positives and negatives. Here we have 4 plus negative 6. They work against each other. 6 minus 4 is going to get me a 2. They work against each other, so I get a 2. Strong on the negative, like the 6. And you can see it here, that that's a positive 4 and a negative 6. The 6 is negative because I created addition. 8 minus 5. 8 plus negative 5. So when you hear the first time 8 minus 5, you hear a minus, you need a plus to show up. We're going to have 8 plus negative 5, you no longer hear a minus, and we get to work. 8 plus negative 5. We got 8 and 5. They don't work together, so we subtract, we get a 3. 8 is stronger than 5, so 3 is positive like our 8. Here we go. 3 dash dash 5, called 3 minus negative 5. I heard minus, so I insert a plus behind the 3. I'll ask class when we're live. I put the plus behind what? And then say 3, and that is correct, because it was going to say 3 minus should be 3 plus the dash dash 5. Right now it's 3 plus dash dash 5. That's 3 plus the opposite of negative 5. So I have 3 plus, and we apply this rule. If the number of dashes is odd, make the term negative. But 2 dashes is even, making my 5 positive. 3 plus 5, 5 and 3 work together to make 8. There's no negatives in sight, so I don't see why anyone would think that's negative, but the 5 is the reason that the 8 is positive. 4 dash dash 2. 4 minus negative 2. 4 plus the opposite of negative 2. 4 plus the opposite of negative 2 is only called 2. The only plus sign I have is the old blue one. These don't do some funky twisty stuff. We don't do keep change something. We have 4 plus the opposite of negative 2. We have 4 plus 2. They work together to get me 6. Strong like the 4 is my 6. That's positive. We got negative 5. So we got dash 5 dash 3. And therefore we have negative 5 minus 3. Shouldn't hear minus. Negative 5 plus negative 3. Working together are my 5 and 3. Getting me 8. So I get an 8. 5 is stronger than 3, so my 8 is negative just like the 5. That addition rule is always true. Once you get it into addition, the stronger of the two terms will determine the sign of the result. Whether you added or subtracted to get here, that rule is true. Dash 2 dash 7. It's called negative 2 minus 7. It becomes negative 2 plus negative 7. They work together. That's a negative, that's a negative. They work together. 7 and 2 work together, get me a 9. 7 is stronger than 2, so 7 is my strong negative. My 9 is negative. I get negative 9. It's negative like my 7. Dash 8 dash dash 2. That's negative 8 minus negative 2. That becomes negative 8 plus the opposite of negative 2. That negative 8 stays negative. It's got a single dash on it. Plus the opposite of negative 2 is 2. It had 2 dashes on it. So I got 8 and 2 working against each other, so I go with 8 and 2, subtract it 6. I get some kind of 6 here, but the 8 is stronger as a negative. I got negative 6. Finally, I'll move it over here. A little more space. Dash 7 dash dash 7. That is dash 7 dash dash 7 like this. Negative 7 minus negative 7. Negative 7 plus the opposite of negative 7. The first negative 7 stays as negative 7. Plus the opposite of negative 7. 2 dashes. Is that odd too? No. So I'm not going to make this 7 be negative. It's going to be that. Plus 7. Negative 7 plus 7. Okay. They don't work together, so I put my 7s up there and I do my subtraction. 7 minus 7 is 0. Is that positive 0? Is it negative 0? Does it matter? We don't call it positive 0. We don't call it negative 0. 0 is 0, so it doesn't have a sign. That's neither positive nor negative. It's neither even nor odd, but it's definitely not positive or negative. It's possible that our numbers will wind up with us hitting 0. So we've got that going on. That's what happens, is conversion of any subtraction into addition of the dash. The old subtraction sign becomes a dash, which may mean that we're now looking at adding a negative number, or it may mean that I've created plus the opposite of something and we deal with it. But what we do is we insert a plus sign in front of any spoken minus. Spoken minus comes right after a value, such as a digit. And then we look at each term. Terms are separated by plus signs to see which ones are positive and negative. And if there's more than one positive term or negative term, we will combine those before we come to this ending part. Now, I'm going to leave that up here while I erase what's here to show you a couple of problems with extended addition subtraction. Here we go. I don't like stringing. Okay, stringing is harder work, and I don't know if you picked up on it yet. I don't like us to work hard. The kind of math I studied in college was applied math, operations research. You want to get as much done with as little expense or energy as possible. So I look to do this in the way that makes it least likely I'm going to make a mistake, and also the way that takes the least work. So everything I do in writing these recipes is to try and create that situation for you. And so we're going to look at this recipe for adding integers. We got negative 3 plus 4 plus 7 minus 6. Okay, here's what that is. It's negative 3 plus 4 plus 7 minus 6. It looks like I wrote the exact same thing, but you heard me say minus. I'm going to put my plus sign right there. What's that get for us? Well, we have a plus sign after the first term, second term, and after the third term. We've got these plus signs. By the way, that plus sign right there is blue, so I'll keep it blue. But those are separating my terms. Now I can move my terms in any order that I want as long as I get all four terms separated by plus signs. So I'm going to leave my -3 up here. And I'm going to swap the 4 with the -6. I'm going to move my 4 to the end and put my -6 right here. And still I have my 7. And if you look, that has a -3, a -6, a +4, a +7, -3, -6, +4, +7, +4. So now, what I should do is get these two guys to make what they make, and get these two guys to make what they make before I figure out one time I'm going to subtract. 6 and 3 make 9, strong like the 6 is negative, plus 7 and 4 make 11, but no negatives in sight, so I've got that, and only one time do I subtract. I say I got 11 and 9, they don't work together, so I do my subtraction, I get a 2, positive is stronger, so I get that. That's my answer. Now I want to take you through stringing so that if teachers encouraged you or let you string, you can see that it gets the right answer, but look at how many times I subtract and have to do weird stuff, and why that makes for harder work. I know you might not believe me, you're like, oh, that was easier. It's riskier. It's quicker because you didn't have to write as much, you didn't have to explain as much, but it's riskier because you're doing more subtraction. Here's what happens. -3 plus 4. I subtract. 4 minus 3 gets me 1, and I recognize that the 1 that I made is stronger as a positive, like the 4. So now I have 1 in front of plus 7. So I got 1 plus 7, which is pretty easy because they're both positive, to make 8. So now I got 8. And then I have to do -6, so I take my 8 minus 6, and I'm lucky enough to have it be positive with my 2. And that's one of the easier kinds of 4-term expressions we could run into. But there are multiple times when I did subtraction there, and times when I had to get the sign right, and then I had to carry a number I couldn't see. There's a lot of risk in that. It did get the same answer too. So stringing isn't wrong, it's just more risky. So let's go with 5-4 plus 6-3 plus 12-40. Okay? What we have then is 5-4 plus 6-3 plus 12-40, and I'm going to put a plus sign anytime I would say minus. So when you hear minus, I'm going to squeeze a plus sign in front of it. 5 minus 4 becomes 5 plus -4, plus 6 minus 3 becomes plus -3, plus 12 minus 40 becomes plus -40. So I'll put in my blue plus signs where they are. I will put in my black plus signs where they've been, and we'll get started. We've decided that what we're going to do is we're going to put the positives first. So I got my 5, okay, then my 6, and then my 12. Those are 5, 6, and 12. Those are positives. And for negatives, I got -4, -3, and -40. Now what I say we should do is 5 plus 6 gets me 11. 11 plus 12 is 23. Now I do my negatives. 4 plus 3 is 7. 7 plus 40 is 47, and that's negative. And now to finish it, what I have is 47 minus 23, because they work against each other. 7 minus 3 is a 4, 4 minus 2 is a 2. I didn't have to borrow, but I got a 24. So this answer is a 24, strong on the negative. That's the way I would recommend you do it, because we only subtracted once. I want to now take you through the process of stringing that some people say, oh, that's what I should do. I should just do the stringing. We'll see. 5 minus 4. 5 minus 4 is a 1. So now I got a 1 before I add 6. 1 plus 6 is 7. So 7 is what I have now. 7 minus 3 is a 4. But 7 minus 3 required subtraction. So I got a 4. 4 plus 12 is 16. And then 16 minus 40 means subtraction again. And you wind up doing 40 minus 16. Done successfully, the 40 minus 16, we run into some trouble with subtraction here. 0 minus 6 I can't do. I want to reiterate how I do subtract. Now if you know to borrow from the 40 and make it 30 and 10, right? You took the 40 and broke it down to 30 and 10. Now you do 10 minus 6 so we can actually handle that, because 10 minus 6 is 4. But if you wanted to, you could also add 4 to the 6 and 4 to that. You get 14 minus 10, and you're going to get your 4 here. And 3 minus 1 is 24. So you'll get it. But I don't recommend stringing. I do recommend getting the positives together and then the negatives together. So that's how we're going to handle our subtracting integers. We're going to turn it into plus dash. Turn the old minus sign into plus dash and go from there. And that's our subtracting of integers work. So I want to touch on word problems a little bit. Oh, groan. You're not in a classroom, so you don't hear the groaning, but word problems are difficult for students because there are many things going on. Number one, you got to do math, all right? You're like, oh, I should do word problems in a math class, but the other thing is you got to deal with the words. You just have to answer the words. These are all problems. Add to that, if English is not your first language, you also have to do the translation of the English words into your own native words. Think through what that is, switch it back to English before you give me the answer. These are all problems with word problems. But I want to look at the words than and from. Are special words for word problems. And they're special words for subtraction word problems. Than or from always is followed by your starting point. Suppose I'm 5 years older than my brother. I'll say JK is 5 years older than GK. Or this. Let's say Kristen is 2 years younger than Paige. Okay. Jeff is 5 years older than GK. What we want to do is we're going to look at it and say the word than is followed by our starting point. So these are all K's. Jeff Knossos, Greg Knossos, Kristen Knossos, Paige Knossos. So we're just going to use the first letter in each one. And in this one, Jeff is going to be equals for word problems. 5 years older than Greg. So we go with than Greg. We begin with Greg, and we make someone older by adding to them. So now, if my brother is actually 51 years old, you can tell how old I am now. Because what we're doing is we're starting with his 51 and adding 5 to it. And so what we want to do when we say than GK, you start with the G and you move from there because you're doing something that's based on G, changing it. Making it bigger, that's fine, plus. Make it smaller, let's go to the other one. Kristen Knossos, we'll go with K is equal sign 2 years younger than Paige. So than Paige tells us, let's start with a P, let's make someone younger by subtracting and put in the 2. Okay? So now if I were to tell you at this point that Paige is 57, you can see that Kristen's 55. But what happens is when you're doing from or than, you're always going to begin your work at the anchoring point. You're based on doing something changing from Greg or something different than Greg, or changing from Paige or something different than Paige. So if I went from Norwalk to Bethel, where did I start? Wait for the answer. If I went to Norwalk from Bethel, that's me starting in Bethel, going to Norwalk. Okay. What if I said I went from Bethel to Norwalk? Where did I start? I started Bethel again. Now, listen for the word from. I went to Norwalk from Bethel. Started in Bethel, went to Norwalk. I went to Bethel from Norwalk, started in Norwalk, went to Bethel. I went from Norwalk to Bethel. From Norwalk, started Norwalk. That's from. So from tells you your starting point. So if I said that I went from Bridgeport to New Haven, where did I start? Answer is Bridgeport. If I said I went to New Haven from Bridgeport, where did I start? Answer is Bridgeport again. And that's what you're going to do when you're saying, I want a number 3 less than 7. 3 less than 7. Then tells me to start with a 7, then make it less by 3. Give me 4. Done. It's not 3 minus 7, because you start with that. Okay? I want, let's see, because I had my than 7, I started at 7. Take 12 from 9. From 9 tells me start with 9, take away 12. You're dealing with 9 minus 12, which is 9 plus negative 12. We've got to deal with what that says, right? 9 minus 12, 9 plus negative 12. And so we got to go with our 12 and our 9. We wind up doing subtraction. We get a 3, but because the 12 is strong, we wind up with negative 3. So then and from are going to tell you your starting point. And it doesn't matter which is said first or second. Than or from tells you your starting point. So you can't just write the letters and numbers and all that across and get it right. You'll get the negative signs wrong and such as that. So that's what's going on with than and from. That's because order matters in subtraction, but order doesn't matter in addition. I'll show you why that is. Take a quick look at why this is what we say. They would say something like a plus b equals b plus a, because it doesn't matter which is first or second. If you have 3 plus 5 equals 5 plus 3, each one is 8. Suppose you have negative 8 plus 2. Is that equal to 2 plus negative 8? It still is. You subtract 8 minus 2, you get a 6, strong on the negative, negative 6. Subtract 8 minus 2, get a 6, strong on the negative, you get a negative 6. So that works. This is called the commutative property of addition. We don't need to know the name, but with addition we are free to move our terms. But now, if I have 5 minus 7, let's go 15 minus 7. Does that equal 7 minus 15? 15 minus 7, we can get into our positions and maybe get this to go, right? Give that 3 more, make it 10. Give that 3 more, make it 18. 18 minus 10, you got an 8. Go to this guy. 7 minus 15 needs to be made into this. So we do our work and we get an 8. But now the 15 is not. No. So order counts in subtraction. It matters what's first. That's why than or from are so important in word problems, because if you do have something that's getting less than or made smaller from an initial point, then you have to know the direction you're going in. So what we try to do is convert them into addition, because I didn't take this thing that was negative 8 plus 2 and ever try and tell someone that that's the same as 8 plus negative 2. When I moved the 2 to the front, it went as positive. When I moved the 8 to the back, it went as negative. The negative stayed on the 8. Right? So that's why we have to convert these all into addition. Now I want to look at what's the opposite of these numbers. Find the opposite of each number. Now the opposite of a number has its sign reversed. I want to say that's it, but I don't want to make you feel bad. But that is all that there is to what we're doing. So if I want to take negative 3, and I want to take 6, and I want to take negative 1/2, and I want to take, and I want to take 3/8, and I want to deal with what they have to get their opposites. So it's not equal, but the opposite. The opposite of negative 3 is 3. Sign has gone from negative to positive. Positive 6 is that. Negative 6 and done. Negative 1/2. Let's find the opposite sign of it. Instead of being negative 1/2, it becomes positive 1/2. The sign changes. It's still 1/2. It's still $half. Instead of owing it, you now have it. 3/8. Instead of being positive 3/8, it will become negative 3/8. These are the opposites that each one does. It's a changing of the sign to reverse the sign. Positive reverses to negative, negative reverses to positive. I want a really important statement here about fractions that are negative. There are 3 places to put your negative sign. There are 3 ways to write a negative fraction. One of them seems to be the easiest, the safest, and in general the best one to work with. Okay, if we have 2/7 and it's negative, some people call that negative 2/7. This is the same as when we have 2/7 with a single negative in it, which might be on the top, negative 2/7. The trickiest one that's also worth the same thing is when we have our 2/7 and we say it's 2/-7. Each one of them is a 2/7. Each one of them has a single dash. Each one's negative. So all 3 of these are the same. I don't like this one because the negative tends to get broken away from numbers and it's floating in space and leads to trouble, but that is negative 2/7. Is a negative value of the fraction 2/7. Given my choice, I prefer to write it as a negative 2 sitting over 7 so that the denominator is positive, because a negative denominator leads to all kinds of difficulties, not impossibilities, but difficulties. And quite honestly, 2/-7 sounds like a math teacher being sneaky, like I'll make it look like it's not too bad because yes, it's a fraction, I'm getting them that way, but then I sneak up and give them a -7 as well. But each one of them is 2/7 with a single negative, and they're all the same. So you need one dash in a position of the numerator, denominator, or in front to make a negative fraction. All right, so that should have you ready to take on homework 1B.